All right, stats, welcome to your notes video for chapter 13 for Friday, January 23rd. We're going to have a quick sponsor shout out. We got college sponsors today of Murray State and SIUE. As always, Laura Bar, proud bar sponsor, and new to the sponsorship, Junkless. All right, no fake stuff. Yeah. This is in your notes packet. Go to the page that says binomial mean and standard deviation. Have a separate sheet of paper out. Separate sheets of paper out, maybe, as well. All right, so number one here, you're a 310 lifetime hitter. That's the probability of success. If X is the number of hits you're going to get in your first 100 at-bats this season, find the mean and the standard deviation. So if N times P is greater than or equal to 5 and N times 1 minus P is greater than or equal to 5, then we can use this normal approximation. Notice how we get a mean and a standard deviation, a population mean, population standard deviation. So that is what is really, really nice. All right, so the mean would simply be N times P, 31. Standard deviation would be 100 in the square root. 100 times 0.31, which is 31. So you can simply do 31 times 0.69. Square root of 2139 is 462. So the mean of that and a standard deviation of that. Nice. This is going to be very, very helpful for us soon. If X is the number of hits you get in your first 200 bats this season, find the mean and the standard deviation. All right, so the mean is 200 times 0.31. Standard deviation is 200 times 0.31 times 0.69, which is 4278 in the square root, which is 6.54. All right. If X is the number of hits you get in your first 500 at-bats this season, find the mean and the standard deviation of X. Mean is 500 times 0.31, which is 155. Standard deviation is 500 times 31 times 69. You can type that in your calculator. You can, you can type it all in at once and under the root. That's fine. Get 10.34. I always do this. I just do 500 times 31 times 69. And I get 106.95. Then I take the square root of that, which is 10.34. Okay. Number two. Your team has won 90% of your games this year. You're going to play in a 5-game tournament where you get a top 3 place if you win 4 or 5 games. What is the probability you don't get a top 3 prize? All right. X is a game that is won. X is a game that is won. All right. So what is the probability you don't get a top 3 place? Means you don't win 4 or 5 games. All right. So it's probability that X is less than 4. Well, you can't win 3.8 games. So I'm just going to do 1 minus the probability of winning a trophy. 1 minus the probability that X is greater than or equal to 4. All right. So the probability that X is 4 is, of these 5 games, again, I can't do the normal approximation here like I did on number 1 because N times P is not greater than or equal to 5 and N times 1 minus P is also not greater than or equal to 5. So I've got to do the binomial distribution. All right, so I have 5 choose 4. Probability of success is 0.9. I'm going to raise it to the 4th. Probability of failure is 0.1. I'm going to raise it to the 1st. I'm going to type that in. 5 choose 4 is going to be 5. Multiply it by 0.9 to the 4th, 0.1 to the 1st, plus 0.9 to the 5th power. All right. And that is, that's great. Got ahead of myself. It's literally circled. That's the probability that you win a trophy. So the probability you don't win a trophy is 1 minus that. Very, very unlikely. But it's not an outlier. Okay. Next up, turn the page. Turn the page. Again, pause this whenever you need to. This is going to get interesting now. All right, so you're going to flip a coin 20 times. Let X be the number of heads you count. Could be heads or tails. Probability is the same. Describe the values of X that should be counted as outliers. Explain your reasoning. Okay, So, expected value of x is the mean, which is n times p. We're going to do 20 times 0.5, which is 10. Okay? So, that's obviously the mean, 50% of 20. Standard deviation is n times p times 1 minus p. Well, 1 minus p is also 0.5. So if I take half of 10, which this is, I get square root of 5. You want to be in classic. The square root of 5 is 2.24. All right, so you're going to have 10 plus or minus 2 times 2.24. All right, so you're going to have 10 plus or minus. Again, to be counted as outliers means you're going to be outside of the mean plus or minus 2 standard deviations. Okay, so I would expect 5.52 to 14.48. So if I had 5 or less, that would be an outlier situation, or if I had 15 or more. If I had 6, not an outlier. If I had 14, not an outlier. Okay? Unexpected result, but not an outlier. Nice. You are a 74% free throw shooter. You're going to attempt 30 free throws during a given stretch. Would making 27 or more free throws be an outlier performance? All right. So we're gonna do this as well. Okay. N times p, and then 1 minus n times p is also greater than or equal to 5. Because if I do 0.26 multiplied by 30, I get 7.8. 22.2 and 7.8 greater than or equal to that 5 threshold we have. I would expect to make 22.2 out of 30 free throws. My standard deviation would be 30 p, 1 minus p, and that's it's going to give me 2.40. You always round to 2 decimals for the mean and the standard deviation. So what I'm going to do, we got to be careful here, because like you'll get, here you get 27 on the dot if you round it to that, which is fine. I rounded this to 3 decimals, but you can round it to 2. No matter if you round it to 3 or 2 decimals, like 27 is barely going to be in there, right? Again, I'm going to do the mean plus or minus 2 standard deviations. 27 is barely going to be in there. So again, some of you might have, because I did say just round to 2 decimals, right? You could have that interval. You could have this to be even more exact. Anyway, 27 makes it barely. 27 makes it barely. All right, so it's not an outlier. It's barely in the 95% of what we would expect. Okay, how many can you realistically expect to make? N times P, 24. The standard deviation, 4.10. Do 24 times 2 times the standard deviation. So that formula won't be given to you. It might say use the 2 standard deviation rule. Might not. So you're going to have to know to take the mean and add and subtract 2 standard deviations. So if I do that, I get 15.8 to 32.2. Can't make 15.8 sales, but you can make 16, all the way up to just below 32.2, which is 32. I'd expect to make 16 to 32 sales. All right, folks, we are doing great. This might be a good time to pause. That junk list bar is looking better by the minute. Pause. You are going to, in a second here, want to get out your separate sheets of paper. Do so quietly. If someone is maybe not paying attention, wouldn't be you guys, no way. We're going to go find this page. This page is later on in your, I think it's later. Maybe not. No, 5. I think it's on a different page. Anyway, it's in your note packet. How many shots should this player expect to make during the season? You're given this situation. 43.5% three-point shooter. He's going to have 300 shot attempts. All right, so we're not ready to do A and B yet, but we can figure out the mean. 300 times 0.435, and the standard deviation, the square root of 300 times 0.435 times 0.565 is the square root of blank, 73.7325. I take the square root of that. I get 8.59. I take 130.5 and I add and subtract twice standard deviation, and that is what I get. I would expect to make anywhere between that. You can leave it as a decimal. That is fine. All right, that is pretty good with notes. I expect you to have that. You guys are going to need, you do not have this. All right. So. We're only 10 and a half minutes in here. You can abbreviate this, but you guys are going to call this. I'm going to call this number 1. I'm going to call it stats assignments. All right, 123. This is from an SIU final. And just write human pregnancy question for this one. Mean of that, standard deviation of that. I do want you to write out part A. What proportion of pregnancies last more than 270 days? X is the length of a pregnancy. So it's probability that X is greater than or equal to 270. This is a chapter 3 question. I have this formula. You might see this. You might have seen it on your... No, you might see it coming up. You just took your chapter 11. Nope. Yeah, you took your chapter 11 quiz, so you've already seen this. You might see this again on your exam. Anyway, 2.5, I look up 2.5. That's 5987. I do 1 minus 5987 to get 4013. What proportion of pregnancies last between 240 and 280 days? Again, need to see this written out, all right, if we want full credit. Some of us just writing answers, we won't get full credit for that. What proportion of pregnancies last between 240 and 280 days? You guys can write fast. Probability at 240, less than or equal to X, less than or equal to 280. All right. Z equals 240 minus 266 over 16. Z is 280 minus 216. It's 266 over 16. I ought to get a z-score of negative 163 and a z-score of 0.88, and I look up the area associated with both, 0516, 8106, and then I, pause this if you need to, I subtract. All right, and then lastly, what is the probability sample of 50 pregnancies has, you can just say lasts 260 days or less. You can say lasts instead of has a mean gestation. Or say like, I guess that has a mean of 260 days or less. All right, so that is a group of 50. So we're gonna say probability that X bar is less than or equal to 260. I'm gonna say Z is 260 minus 266. Again, I need to see this work or we're not getting credit. Is equal to a negative 6 over some number. You want to be in classic, because if you do 16 divided by the square root of 50, it's going to break it down as a root. Negative 2.65. Again, don't approximate this number. Do 16 divided by the square root of 50, 2 point something, and immediately do negative 6 divided by answer. You get 0040. Nice. This brings us now to chapter 13. Has a binomial distribution. Bin there, interesting, 100.4 mean and a standard deviation given. So, all right, and I'm sorry, it's n times p, not mean the standard deviation. I would go back and, that's for a normal. Go back and edit that out, but you know I don't. So that is the number and the probability, All right, so the mean is, we're gonna make it a mean and a standard deviation. The mean is 100 times 0.4. Standard deviation is 100 times 0.4 times 0.6. It's greater than 24. Again, if you're in math print, 2 root 6, we need a decimal. 4.90. You are going to call this question 2. And honestly, question 2 is just question 2. It doesn't really have A, B, and C. Pause this, go back up, all right, because I want to see a question written out, and I want to see this work. All right, we simply have answers and nothing written out. We will not get full credit, I think. Some of us need to hear that more than others, okay? And this happens to be the last question. We're going to call this question 3. Yes, make out the table. Pause. Math 282 grades are given below. Math 282 is basically the Intro to Stats course you were taking at SIU Carbondale. So section, you got M and other, A, B, C, D, F, row total, and then column total. Make that table for me. And then A, find the probability a randomly selected student got an A. So you simply do 30 over, it's a randomly selected student, 30 over 163, easy peasy. B, find the probability a randomly selected student got an A given that they were in section M. Yes, write that out, you can do it. Probability of A given section M. Well, section M, now 25 is my denominator, and A, 11 is my numerator. And then find the probability that a randomly selected student got a D or F. That's out of everybody again, so 163 is my denominator. D and F. And 41 over 163, folks, I believe you can do it. 0.25 something. Anyway, this notes video, if you are in class tomorrow, is it's due at the end of the hour. All right, I told our sub to mark any that are turned in later in the day as late. If we are not in session Friday, then you're going to turn it on Monday. Okay, if we have a not be in session Friday and Monday, then obviously it's due Tuesday. All right, folks, we shall talk next time I see you in person. This is Yak Math Videos, signing out.